Hi dear students, this video consists of the questions from the chapter Chemical Bonding of +1 NCERT syllabus which were asked in the previous year's Neet exams from the year 2020 to 2021. Please listen. Question number 1. Which of the following set of molecules will have zero dipole moment? Option number 1, boron trifluoride, beryllium difluoride, carbon dioxide, 1,4-dichlorobenzene. Option number 2, ammonia, beryllium difluoride, water, 1,4-dichlorobenzene. Option number 3, boron trifluoride, hydrogen fluoride, carbon dioxide, 1,3-dichlorobenzene. Option number 4, nitrogen trifluoride, beryllium difluoride, water, 1,3-dichlorobenzene. Listen, here among the compounds given in the options, boron trifluoride, that is BF3, beryllium difluoride, BEF2, carbon dioxide, CO2, and 1,4-dichlorobenzene are symmetrical molecules. Therefore, the dipole moments due to the bonds formed between atoms of different electronegativity cancel each other. That is, BF3 molecule has trigonal planar geometry. Since fluorine is more electronegative than boron, the bonding pair of electrons are attracted towards fluorine. Combined of these two forces of attractions acts along this direction. There is a third fluorine which is on the opposite direction. Therefore, these three forces of attractions cancel each other mutually. Therefore, the dipole moment of this molecule, that is mu, is equal to 0. Beryllium difluoride is a linear molecule. Therefore, the two fluorine atoms are on the opposite side. Therefore, the force of attractions acts along opposite direction. So, here also mu is equal to 0. Similarly, in the case of carbon dioxide and 1,4-dichlorobenzene, the force of attractions acts along opposite direction. Therefore, their dipole moment also is equal to 0. So, here the answer is option number 1. Then question number 2. Match the compounds of xenon in column number 1 with the molecular structure in column number 2. Two columns are given. Column number 1, the compounds of xenon are given. In column number 2, their structures are given. We are asked to find out the structures of these compounds from column number 2. And these are the options given. The easy method to calculate the number of hybrid orbitals of the central atom, that is n, is equal to number of valence electrons of central atom plus number of monovalent atoms attached to central atom plus or minus charge divided by 2. And number of lone pairs is equal to number of hybrid orbitals, that is n, minus number of groups attached to central atom. Now we can find out the structure or shape of molecules of xenon one by one. First of all, xenon difluoride XeF2. Here the central atom is xenon, therefore number of valence electrons is equal to 8, and the number of monovalent atoms, there are 2 fluorine atoms, that is equal to 2. Therefore, number of hybrid orbitals n is equal to 8 plus 2 by 2, that is equal to 5. If the number of hybrid orbitals is equal to 5, the hybridization will be sp3d. And the number of lone pairs is equal to number of hybrid orbitals 5 minus number of groups, that is 2 fluorine atoms are attached to xenon. Therefore, 5 minus 2, therefore lone pairs is equal to 3. sp3d hybridization with 3 lone pairs. Therefore, the shape or structure of molecule is equal to linear. The second compound is XeF4, xenon tetrafluoride. Here also valence electrons 8, number of monovalent atoms 4 because there are 4 fluorine atoms by 2, number of hybrid orbitals n is equal to 6. Therefore, hybridization will be sp3d2, and the number of lone pairs is equal to number of hybrid orbitals 6 minus number of groups. There are 4 fluorine atoms, 6 minus 4 is equal to 2. That is sp3d2 hybridization with the 2 lone pairs. Therefore, the shape or structure of molecule will be square planar. Now, the third compound is XeOF4. The number of hybrid orbitals n is equal to the valence electrons 8 plus the number of monovalent atoms 4, because here oxygen is not a monovalent atom, by 2, therefore number of hybrid orbitals is equal to 6. So hybridization is sp3d2. Number of lone pairs is equal to number of hybrid orbitals is 6 minus number of groups attached to central atom, that is 5. So lone pairs is equal to 1. That is sp3d2 with 1 lone pair. Therefore shape of the molecule is square pyramidal. Now the last compound is HCO3. Here number of hybrid orbitals N is equal to valence electrons 8. There is no monovalent atom, therefore it is equal to 0. Therefore hybrid orbitals is equal to 4. So hybridization is sp3 and lone pairs is equal to number of hybrid orbitals is 4 minus number of groups is equal to 3. That is lone pair is equal to 1. sp3 hybridization with 1 lone pair. Therefore shape or structure of the molecule is pyramidal. So here the answer is option number 4. Now question number 3. Identify the wrongly matched pair. In this column some molecules are given, and in this column shape or geometry of molecules are given. Option number 1, the molecule is PCl5. Its geometry is given as trigonal planar. Option number 2, SF6 is a molecule and its geometry is given as octahedral. In option number 3, BeCl2 is a molecule and its geometry is given as linear. And option number 4, the molecule is ammonia and its geometry is trigonal pyramidal. We need to find out the wrongly matched pair. You please listen. Now we can find out the geometry of molecules one by one. First of all, PCl5. For PCl5, number of hybrid orbitals N is equal to its valence electrons 5 and number of monovalent atoms 5 divided by 2. Therefore, number of hybrid orbitals is equal to 5. So hybridization is sp3d. Number of lone pairs is equal to number of hybrid orbitals 5 minus number of groups attached to central atom, that is also 5, that is equal to 0. That is sp3d hybridization with no lone pair. Therefore the shape of the molecule is trigonal bipyramidal. The second compound is SF6. Number of hybrid orbitals is equal to its valence electrons 6 and the number of monovalent atoms 6. There are 6 fluorine atoms by 2. Therefore number of hybrid orbitals is equal to 6. So the hybridization is sp3d2 and the number of lone pairs is equal to number of hybrid orbitals minus number of groups, that is equal to 0. sp3d2 hybridization with 0 lone pair. Therefore shape of the molecule is octahedral. Now the compound is BeCl2. Its valence electrons 2, number of monovalent atoms also 2 by 2. Therefore number of hybrid orbitals is equal to 2. Therefore hybridization is sp. Number of lone pairs is equal to number of hybrid orbitals minus number of groups, that is equal to 0. sp hybridization with no lone pair. Shape of the molecule is linear. And the last compound is ammonia. Here number of hybrid orbitals is equal to valence electrons of 5 monovalent atoms, that is 3 hydrogen atoms divided by 2. Therefore number of hybrid orbitals is equal to 4. So hybridization is sp3. Number of lone pairs is equal to number of hybrid orbitals 4 and the number of groups attached is equal to 3. Therefore lone pairs is equal to 1. sp3 hybridization with 1 lone pair. Therefore shape of the molecule is pyramidal. Here in this question, the shape of PCl5 molecule is given as trigonal planar. So here the answer is option number 1, that is a wrongly matched pair. Then question number 4. How many, first one sp2 hybridized carbon atoms and second one pi bonds are present in the following compound? This is a compound given. Option number 1 7, 5. Option number 2 8, 6. Option number 3 7, 6 and option number 4 8, 5. Listen, if the structural formula of a carbon containing compound is given, its hybridization can be easily determined by calculating number of sigma bonds around it in that molecule. Here in this compound, all the 6 carbon atoms of benzene ring and the carbonyl carbon of this ester group are under sp2 hybridized state. Because each carbon atom forms 3 sigma bonds, therefore number of hybrid orbitals is equal to 3, so hybridization is sp2. So here number of sp2 hybrid carbon atoms in this compound is equal to 7. Number of pi bonds in this compound is equal to 1, 2, 3, 4, 5, 6. So here the answer is option number 3. Now question number 5. BF3 is planar and electron deficient compound. Hybridization and number of electrons around the central atom respectively are. Option number 1 sp2 and 6, option number 2 sp2 and 8, option number 3 sp3 and 4, and option number 4 sp3 and 6. In BF3 molecule, the central atom is boron. Its number of hybrid orbitals n is equal to number of valence electrons 3 plus number of monovalent atoms attached to boron, that is also 3 by 2. So number of hybrid orbitals is equal to 3. So hybridization is sp2. Number of lone pairs is equal to number of hybrid orbitals minus number of groups attached to central atom, that is also 3. So lone pairs is equal to 0. That is sp2 hybridization with no lone pair. Therefore shape of the molecule is trigonal planar. This is a Lewis representation of BF3 molecule. The outermost shell of central boron contains 1, 2, 3, 4, 5, 6 electrons. So here the hybridization of boron is sp2 and the outermost shell contains 6 electrons. So here the answer is option number 1. Question number 6. Which of the following molecules is non-polar in nature? Option number 1 SbCl5, option number 2 NO2, option number 3 POCl3, and option number 4 CH2O. We know symmetrical molecules are usually non-polar because the dipole moment due to the individual bonds cancel each other. Here among the given compounds, SbCl5, that is antimony pentachloride, is a symmetrical molecule. It has a trigonal bipyramidal geometry. Here these 3 chlorine atoms are oriented along the 3 corners of an equilateral triangle. Therefore the force of attraction due to these 3 chlorine atoms cancel each other mutually. Here one chlorine atom is above this plane and another one is below this plane. That is, these 2 chlorine atoms are in opposite direction. So their force of attractions also cancel each other. So here SbCl5 is a non-polar molecule and all the other given molecules are polar. So here the answer is option number 1.